Astronomers have witnessed 5 massive explosions on the planet Jupiter as fragments from the Shoemaker-Levy collided with the planet. Larger explosions are expected later this week.
They called it the biggest explosion in the solar system for hundreds of years. Half an hour after the first comet fragment went in, the impact was still visible. The cloud of debris spread out for thousands of miles and was over 1,000 miles high. The astronomers were jubilant.
We're going to see things and we're going to learn a lot. That's the good news tonight.
Before Newsnight, more of the unfolding story behind the week's dramatic events on Jupiter. Tonight, how the comet Shoemaker-Levy was turned into a train of fragments thousands of miles long.
In space, size is everything. And in our solar system, nothing is more important than the sun. The gravitational pull of this huge fireball holds planets, moons, and comets in its grasp. But one planet, Jupiter, is big enough to regularly steal smaller bodies away from the sun's influence. Its most recent victim was the comet, Shoemaker-Levy. Trapped in a short orbit around the red giant, it was only a matter of time before things turned nasty. 2 years ago, the comet passed within a few thousand kilometers of the planet's surface, a hair's breadth in astronomical terms. The tension between falling down to the planet and continuing to orbit was too much. Cracks and fissures opened, vast quantities of dust broke off, and as the comet wrenched itself clear, it was torn to pieces. The ruptured rock retreated out to space in a train of rubble 10,000 kilometers long, with a string of mountainous fragments in the center. But its fate was sealed. Jupiter not only had torn it apart, but fatally changed its orbit. So when it came back, there would be no near miss. On the 1st of July, an hour before dawn, a meteor shower hit the planet Jupiter. This storm of shooting stars was the vanguard of the comet, Shoemaker-Levy. Already ripped apart by Jupiter's gravity, the planet was now beginning to finish the job. Last Saturday, the comet's large core fragments started to slam into the atmosphere, mountains of rock vaporizing in seconds. Tonight, the largest rock struck. A fireball rose hundreds of kilometers above the surface, creating a hole in the atmosphere larger than Earth. Shock waves will ripple around the planet for days, and its surface may be changed for weeks. In the end, Jupiter's stormy red atmosphere will close over the scars left by Shoemaker-Levy. But there are always more rocks out there, and other planets, where such huge impacts would not be so easily.
Right, that's after the last of this week's Jupiter Animations, which looks at the lessons that Earth can learn from this momentous collision.
As the fireworks die down on Jupiter tonight, and the last of the fragments of the comet Shoemaker-Levy throw themselves against its atmosphere, the likelihood that something similar could happen to us here on Earth seems very remote. In fact, 400,000 tons of material falls on Earth every year. Most of this is dust that burns up in the atmosphere as shooting stars, but frequently larger rocks, big enough to release kilotons of energy, detonate high above Earth's surface. There are also bigger flying mountains out there. A reservoir of these lie out beyond Mars in the asteroid belt. Occasionally, this belt can be disturbed by Jupiter's gravity, and then an asteroid is pushed into the inner solar system to orbit among the minor planets until there is a collision. This has probably happened many times in our planet's long history, and if so, it would have had a profound effect on life on Earth. Should a Shoemaker-Levy-sized object target Earth in the future, we could go the same way as the dinosaurs.
I saw this on my computer screen when I was taking photographs of Jupiter at about 1 o'clock in the morning, my time, Monday morning. I'm a regular photographer of Jupiter, and I'd taken a picture of this same part of Jupiter 2 days before, and it was pretty clear to me that this black spot was not there 2 days before.
What does it look like to you? What is it?
Well, when you look at it through a telescope, it just looks like a black dot, and really all you're seeing is a lot of deep down material in Jupiter's atmosphere that's been thrown upwards by this explosion.
Now, it is said to be the size of the planet Earth. That's enormous. This is something massive, isn't it?
Well, it just goes to show the scale of the planet Jupiter. The mark that you're showing now, that your viewers are looking at, is approximately the size of the Earth. And Jupiter, of course, is just so much more massive. That spot, in Jupiter terms, isn't really going to do it any lasting damage at all.
Now, it's amazing to me, first of all, that you've discovered this, but you said it was at 1 in the morning your time. Are you frequently up till 1 a.m. taking pictures of Jupiter?
Well, I am sometimes. The weather conditions around here, of course, we're in our middle of our winter at the moment. The weather conditions were close to freezing, and I have to say to you that it was a very near thing. I almost closed up and turned all the gear off about an hour before that. And for whatever reason, I decided to keep going for a little while longer, and just a while after that, this impact mark rotated around into view. So it was very close.
Well, you know, a lot of people are up at that hour, but most of them are watching TV, and I gather you were watching TV too when this happened.
Well, you know, my telescope was competing with two other of my great interests, and that is the cricket and the golf. I have to say I did come up and take a break for about half an hour and watched some of the final round of the British Open.
The British Open and the Ashes. So, let me ask you, who do you call when you spot something like this? What did you do?
Well, that was another great dilemma for me. I didn't know at that stage whether anybody else was recording this data. So first and foremost, I thought the most important thing I can do is keep recording data so that I can generate some images to show other people what's going on. But by about 2 o'clock in the morning, I'd really given up on that and was now back up at the house trying to email some of the colleagues that I have around the world and some contacts I have, in particular, people, other professionals, such as the people at NASA with larger telescopes.
Had anyone else seen it?
As far as I know, and this is still very early days, as far as I know, nobody else was recording Jupiter at that time. So I don't think anybody else saw this on its first pass around being visible to the Earth. By the time the second pass happened 10 hours later, when Jupiter had turned around and was showing us that same place again, of course, there was massive interest starting at that time, so a lot of people recorded it from the second time around.
Now, we have been showing NASA's image of the spot until now. We have your image, the picture you yourself took, and I think we're going to put that up. There it is. You don't really notice it right away. You need a pretty good eye. You need to be looking in the right place. As we look at this, I'm just curious about this. Are they going to call it, is it going to be named after you? Is this now the Wesley Scar, the Wesley Spot, the Wesley Eruption?
Well, it's only likely to last for 1 to 2 weeks. Based on the images from the Shoemaker-Levy 9 comet collision back in 1994. Back in 1994, that was a much larger series of collisions, and those marks looked very much like this when it happened, but within 2 to 3 weeks, pretty much all of that material had just disappeared.
Now, you mentioned 1994. That was the last really big hit that anyone noticed on Jupiter. How often does this kind of thing happen? And frankly, seeing it happen on Jupiter, how worried should we be about it happening to us on Earth?
Well, look, Jupiter is doing a very good job in scooping up a lot of this material that's still floating around in the solar system. It's just got so much gravity. As it swings around the outer part of the solar system, it can really pull in and swallow up many of the cometary objects and debris left over from the formation of the solar system. So it's doing a good job in keeping us safe by cleaning out a lot of these bits and pieces.
Let me ask you a question that may be obvious to the scientists out there, but isn't obvious to me. Whatever hit Jupiter caused an enormous impact, an enormous amount of energy. What would it have sounded like?
If you were close enough to hear it, I don't think you'd have survived it, I think is the short answer to that one.
But this is an enormous explosion, bigger than anything we would have ever experienced on Earth, bigger than anything we could have lived through.
Well, that's certainly true. The impact mark, again, that you're showing on the screen, the impact remains, covers an area about the same diameter as our planet. So it's likely that the impacting body was something in the order of 50 to 100 miles across and moving at speeds of somewhere around 50 to 100 kilometers per second. Now, that generates an unbelievable amount of energy when it collides with pretty much anything, but especially with something the size of Jupiter.